Okay, so here's the second half of 3.2. We have three more functions to go over. So the square root function. So the square root function is f of x equals the square root of x, and this is without any shifting left, right, or whatever, up, down. So it basically starts at 0, 0, and I call it like a shooting star. It kind of goes out of the origin and it just sort of shoots off. It does, even though it looks like it's flattening out, it does actually keep going up and up and up and up and up, just very, very slowly. So that is the square root of x. So now what we can do, just like all the others, we can shift it left, right, and whatever. So we're going to look at our vertex here. So our vertex is going to be the opposite of what's happening to my x. So I'm going to have -2 and the same as what's outside, so -2, -3. So if we come down here, -2, -3. So this is basically what my graph is going to look like. So my domain. So my domain are my x values. So what x values are part of this graph? Well, my x values start at -2 and they go to infinity. So we're going to have -2 to positive infinity, and it includes -2. And our range are our y values. So what is my lowest most y value? Well, my lowest most y value is right here. So it's -3 and it goes up to infinity. So -3 to positive infinity. My x and y intercepts, just like always, y equal to 0, x equal to 0. So if I go up here and for this f of x, I plug in 0 for that y or that f of x, I'm going to get 0 equals the square root of x plus 2 minus 3. So before I can square both sides, I have to get rid of that 3. So I'm going to have 3 equals square root of x plus 2. Now I can go ahead and square both sides. So I end up with 9 equals just x plus 2. Subtract the 2, so 7 equals x. So I should have an x-intercept somewhere around, or at, 7, 0. So I didn't draw my graph very well. It should have been way down here. So the graph really should have been drawn more like that than that first one. And now the y-intercept. So if I plug in 0 up here, I'm going to get, let me do this down here. So if I plug in 0, I'm going to get 0 plus 2 minus 3. So that's the square root of 2 minus 3. And I'm just going to plug that in my calculator to get a decimal approximation for that. So I'm going to get square root of 2, oh sorry, minus 3. I should need to change that to minus 3, is -1.6. That should be a 3. So this is about -1.6. So let's see if that makes sense on my graph. So I should have a y-intercept at 0, -1.6, and 0. Yeah, that's about right, right? Like, you know, my very rough draft there, or rough graph. Okay, so now let's see when it's increasing and decreasing. So this graph is always going up. So there's not going to be any decrease on this graph, right? It's never switching around and going down. And it is always increasing. And remember, we're talking about our x values. So my x value starts at -2. So it's increasing from -2 forever. So it's -2 to infinity. So it is increasing from -2 to infinity. Okay? Two more. Cubic functions. So the cubic function, the basic graph looks like this. So again, I'm going to look at an example. So let's just say f of x equals x minus 2 cubed minus 8. Something like that. So now I'm going to look at, well, first let's look at our vertex. Our vertex is going to be opposite and same as always. Are you guys noticing a pattern yet? So opposite is +2, -8. So if I draw a graph, +2, -8 might be way down here. And basically what I do is I just kind of swing an arm this way and swing an arm that way. Oops, oh, you couldn't see what I was doing. I'm sorry. I did my vertex and I swing it around this way. You just get in the habit of doing this, going around this way and then turning it around and going that way. It's easier than kind of swiveling it, I think. because you always have to start with that critical point. If you notice the pattern that I'm always finding the critical point first. All right, there's a reason I do that. So my domain. For all of these cubic graphs are really nice. They're going to be negative infinity to infinity. Always, always, always going to be the same. And the range is always, always, always going to be negative infinity to infinity. So these are nice. These are repeated ones. If you look at this graph, you can see the x values are going to continue to expand, and the y values obviously go all the way up and all the way down. So x-intercept, y equal to 0, x equal to 0. So for my y-intercept, let's go ahead and plug 0 up in here. So I'm going to get 0 equals x minus 2 cubed minus 8. So now I'm going to add 8 to both sides. So 8 equals x minus 2 cubed. So now I can take the cube root. So the cube root, because now that the cube is by itself, I can take the cube root. And the cube root of 8 is, you remember when it's odd, when your powers are odd, you do not need to do the plus and minus. You only need to do the plus and minus when they are even. So the cube root of positive 8 is only going to be positive 2 equals x minus 2. So now I add 2 to both sides, so x equals 4. So remember all of this was finding the x-intercept. So the x-intercept is 4, 0. That looks about right, because remember we started at 2 and looks like about 4, right? And I got lucky on that one. And then if I plug 0 in on this graph up here, so I'm going to have y equals 0 minus 2 cubed minus 8. So I'm going to have, this is going to be negative 2 in parentheses cubed minus 8. Well, negative 2 cubed is actually going to be negative 8, because negative times negative is positive, times another negative is negative. Minus 8 equals negative 16. So my intercept is going to be 0, negative 16. And that kind of makes, well, actually I should have probably swung it down a little bit harder, but it's going to be way down here on the y-axis. Okay, and increasing and decreasing. So this graph, now even though we have arrows, remember, don't let these arrows fool you. The arrows just, they're showing a different thing. They're not showing, the arrows don't have anything to do with increasing or decreasing. They're just saying that this line continues on in this pattern in this direction, and this line continues on in this pattern in this direction. But when we're talking about increasing and decreasing, we're reading the graph from left to right. So as I start at the furthest most left point, can you see that I'm going to be, this is continuing to move over and over and over and over and over. So it's really going from negative infinity all the way up to infinity. So this graph is only increasing from negative infinity to infinity, and it is never decreasing. Now if we will get to the negatives of these, so when I do switch this around and I make it a negative, then the entire graph will be decreasing and it will never increase. But this graph, as I go from left to right, if I were riding on this wave or whatever, riding on this roller coaster, I would be constantly going uphill in some pattern, okay? So if you're going uphill from left to right, then you are increasing. Okay, last one. Cube function. So the cube function basically looks a lot like the cube root function looks a lot like the cube, except it's on its side. So here's the cube function, and if I take it and I actually rotate it, I get the cube root function. So here's an example, opposite and same. So we're going to get our vertex at 2, 2. So 1, 2, 1, 2. And what I'm going to do is I'm going to start at that vertex and go off that way and then go back down this way. Okay? So my domain, these are really nice. My domain is always, always, always going to be negative infinity to infinity. Those are my x values. And my range is also always negative infinity to infinity. Even though it looks like it's flattening off, it's really not. It really will cross that x-axis and continue to move down. So those are nice. Okay, set y equal to 0, set x equal to 0. So let's do the easy one first this time. If I plug 0 in here, I'm going to get the cube root of 0 minus 2 plus 2. So the cube root of negative 2 plus 2. So remember, if I have a negative under a cube root, that is actually fine, because you can have negative times negative times, is positive times negative. So this is not an imaginary number. So on my calculator, I'm going to do the cube root, and I'll show you guys in class how to do cube roots on your calculator. So I'm going to do negative 2. I'm just going to get a decimal for this. To the plus 2. And I get roughly 7.4. Or sorry, 0.74. So this is about 0.74. So that means I'm going to have a y-intercept at 0, 0.74 roughly. And that looks about right, right? Actually, I drew that really well. Surprise, surprise. And now, if I plug 0 in this function up here, 0 equals the cube root of x minus 2 plus 2. I can subtract 2 over. So negative 2 equals the cube root of x minus 2. And now that the cube is by itself, or cube root is by itself, I can cube both sides. So negative 2 cubed is going to give me negative 8 equals x minus 2. And I can add 2 to both sides, so x is going to be negative 6. So somewhere down here, 1, 2, 3, 4, 5, 6, somewhere down here it's going to cross that x-axis. And that intercept is going to be at negative 6, 0. Okay. Increasing and decreasing. So remember, I'm reading from left to right. So as I'm riding along from left to right, can you see that I'm constantly, I know I'm turning a little bit, but I'm still always going in an uphill motion. I'm never turning downward. So this is increasing. This one is increasing from negative infinity to infinity, and it is never decreasing. Okay. So what I want you to do right now is I actually want you to go ahead and draw yourself just a quick little grid, just a quick little axis for each one of these. And then I want you to stop the video. I want you to promise me you will stop the video, and I want you to see if you can draw these graphs from memory, just the basic graph without any shifting. See if you remember what they all look like, and then turn it back on and see if you can see if they look like mine, okay? So go ahead and stop it, and I'm going to go ahead and draw mine. So hopefully that's what you got.